In this video, I'd like to look at two logarithmic equations. So the first one is log of 1,000 equals x. Now, in general, when you have an equation of the form log base b of u equals n, so when you have log on one side equals something that's not a logarithm on the other side, then in general, the best way to approach equations like that is to change it to the exponential form. The exponential form, which in this case would be, so the base is b, the exponent is n. That's log's job, is to find the exponent. What power of b is equal to u? So when a logarithmic expression is equal to n is the exponent that we put on b in order to get u. So the exponential form of this equation is b to the n equals u. Okay, so if we take that over here and apply it, then the first thing we want to ask ourselves is, well, what's the base? I don't see a base. So remember that when you don't see a base, it's implied that this is the common logarithm whose base is 10. And so when you put this in the exponential form, it's 10 raised to the x power equals 1,000. And this is one that we could actually solve by inspection. So what power of 10 is 1,000? That's 3. And in fact, this is one that we could solve just based on evaluating the logarithm. So the common log of 1,000, that's what power of 10 gives me 1,000? Well, the answer is 3. I mean, it's possible to just reason this solution just looking at that logarithmic expression. Now that might be not so much the case with this second example over here. So let me shift over to the equation 4 times natural log of 2x equals 20. And suppose we're trying to solve that equation for x. The first thing that we should do is isolate the logarithm in this equation. Just in general, with these logarithmic and exponential equations, you want to isolate the most complicated part of the problem to start this out. So in this case, I'd want to isolate ln of 2x. So I would divide both sides by 4. And that gives me natural log of 2x equals 20 divided by 4, which is 5. All right, so again, I don't see a base written. I have to remember what the implied base is. When it's natural log, that's implied that the base is e. And so the exponential form of this equation is, okay, base is e raised to the 5th power, log always equals the exponent over here, is equal to 2x. I know that because I know that natural log of 2x, the task that this natural log operation accomplishes is it determines what power of the base, in this case e, gives me 2x. So when it's equal to 5, that means that e to the 5th power gives me 2x. So this right here is the exponential form. It's an equivalent form of that original equation. Okay, well then now if we want to isolate x, I just need to divide both sides by 2. And so in this case, x equals e to the 5th divided by 2. Notice that both of these equations, the primary task is to change it to exponential form. If you can understand that, then the rest of the solution is fairly simple.